The Sun is the largest star of our solar system. It is located at the center. Around it revolves 8 different planets and several dwarf planets. These planets revolve around an elliptical orbit at different speeds and of different time. One of these dwarf planets is the planet Pluto, which is located farthest from the Sun.
The problem. According to Kepler's law, planets have elliptical orbits, with the Sun at one of the foci. The farthest Pluto gets from the Sun is 7.4 billion kilometers. The closest it gets to the Sun is 4.4 billion kilometers. The question: find the equation of the Pluto's orbit assuming a center at the origin.
Let us imagine that we are in a Cartesian plane. The problem states that the Sun is one of the foci of the elliptical orbit Pluto, revolving around it. We can simply call it F2, since the nearest possible distance of Pluto can be noted as V2. The problem states that the distance of V2 from F2 is 4.4 billion kilometers. We can assume that the distance of V1 from S1 is also 4.4 billion kilometers.
The farthest distance of Pluto from the Sun, or F2, according to the problem, is 7.4 billion kilometers. Since we've already found out that the distance from V1 to F1 is 4.4 billion kilometers, we can subtract this number from 7.4 billion kilometers. To get C, divide 3 billion by 2, resulting in 1.5 billion kilometers. The next step is to find A, or the distance from the center to each vertex. Since we already know that the distance from the center to the foci is 1.5 billion kilometers, we can simply add to this to 4.4 billion, or distance from the foci to the vertex. To get A, the result is 5.9 billion kilometers. In order to get the value of B, or the distance of the co-vertices from the center, we will make use of the formula C squared is equals to A squared minus B squared. Substitute the values and get the square root. B is equal to square root of 32.56. Since we already had the values of A, B, and C, we can now write the equation of the ellipse. X squared over A squared, or 34.81, plus Y squared over B squared, or 32.56, is equals to 1. This is assuming that the ellipse is horizontal. If we consider the vertical positioning, the equation would be y squared over 34.81 plus x squared over 32.56 is equals to 1.
This video was brought to you by STEM MARCONIC, school year 2018 to 2019. Please remember to hit the like button and subscribe for more videos and math tutorials.